So we've talked about the difference of two squares. Today we're going to talk about the sum and the difference of two cubes. For cubic values, you can do a sum and a difference. That's not true for the perfect squares, but it is true for the perfect cubes. So we're going to write out your two patterns. The sum of two cubes, if you're adding two perfect cubes together, then you can factor it into a plus b times a squared minus ab plus b squared. Okay, and then when you have the difference of two cubes, this is very similar. Okay, and the pattern is a minus b, a squared plus ab plus b squared. Okay, so these have some similarities and some differences. One thing you probably notice right away is that the sum means that you have a plus first. The difference means you have a minus first. And then if this starts with plus, the next sign is minus. If this starts with minus, the next sign is plus. But they both end in a plus b squared. Let's think about why that is mathematically. If you're squaring a value, why does it always have to be positive? Because a negative times a negative is a positive, right? And so is a positive times a positive. So that's why that's always going to happen like that. Now, when you're doing the sum and difference of two cubes, when we get into some of the more complex examples, remember that you still have to check for the GCF. So still take out your greatest common factor. That'll actually make this easier for you if you do that, because you'll be working with smaller numbers. And then the trinomial, which is this, right? Trinomial, three terms. The trinomial in this pattern is not factorable. So never worry about trying to factor that. It's not factorable. So the trinomial in the sum or difference of two cubes is not factorable. Okay, so you never have to try to break that down further. Okay? All right, so before we do examples, we have to be familiar with what perfect cubes are and how to generate them. So you guys are really good at the perfect squares now. The first perfect square is 1. The second one is 4. The third one is, and then 16. What's the next one? 25.
36.
Okay,
49.
and then where are these coming from? How can we generate them so fast? Yeah, 1 times 1, right? 2 times 2, 3 squared, 4 squared, 5 squared, 6 squared. So the cubes are the same, except now we're going to take those numbers and do what? Yep, or just raise them to the third power. So let's write out our perfect cubes. This is going to be a handy list for you. Okay, so with your perfect cubes, the first one is 1. That's because that's 1 to the third power, or 1 times 1 times 1. Okay, so what's 2 to the third power? 8. Good. 3 to the third?
27.
Yeah. So when you're doing 4 to the third, 4 times 4 is 16. Yeah, we do, and then 16 times 4 is? Thanks. Hey, Kai, will you grab the door for me? And then I think you guys know 5 cubed.
125.
Yep. Okay, now we're going to go up to 10. The 6 cubed, I don't expect you to know that off the top of your head right now, but you will get used to seeing these numbers the more that you practice them. So you naturally are going to start to recognize them. And then this section is a no calculator section for the most part. Like, you have to know how to do it without it. But some of the bigger numbers we are going to use a calculator on. And that's why I'm giving you the bigger ones, okay? Which you could do that on your calculator. Except for 10, because 10 to the third power, you just have to put how many zeros? Yep. So if it's to the third power, you put the 3 zeros on the 1. Okay, so this isn't something you necessarily have to memorize because you can always find them by multiplying, but if you do start recognizing the numbers, that's going to make this a little bit easier for you. Okay, so when we're applying the pattern, one giveaway that you're going to use the pattern is the third power. Okay, that should be a big clue. And then you're either going to be adding or subtracting another number. So when you set this up, a good thing to ask yourself is, what to the third power is y cubed? That, of course, would be y. And then for 512, we're going to use our chart. So 512 is formed from 8 to the third, so we're going to plug in 8. And that's going to be your A and your B. So your A value is y, your B value is 8, and I'm going to write above this what the pattern is, okay? So A plus B, A squared minus AB plus B squared, and then we're going to fill in this pattern together, okay? All right, so A plus B is just y plus 8. A squared is now y squared. Y times 8 is 8y. This stays minus. B times B is 8 times 8. 8 times 8 is 64. This is your final answer. Okay, that trinomial is not factorable. All right, so let's do it again for this one. So again, you're starting by asking yourself, what cubed would make 125d cubed? So most of you already know right away the 5 is needed, and then your variable, you're going to put that in with it. And then notice that the minus is just going to stay here. You are not going to put it inside the parentheses. The pattern, the difference pattern already accounts for that. So when you're plugging this into your pattern, your A value is 5D, your B value is 2. Okay, so let's write this in. So it's A minus B. So A minus B would be 5D minus 2. No, because this is minus. Yep, so for the difference of two cubes, we're going to be using the A minus B, A squared plus AB plus B squared. And then, what is 5D times itself? 25D squared. So don't forget the 25, because that can be tricky. And then 5D times 2 is 10D. And then 2 times 2 is 4. Okay, and the more that you practice that, the easier it will become. Okay, and then for C, again, remember I said the first thing that you want to take out is the GCF. So we know that 2 goes into both of them. I would see if 8 goes into both of them. And since we're just starting this, I'm gonna let you use your calculator for that. Okay, so let's see if 8 goes into 216 evenly. Does it? How many times? Okay, and that's a nice number. Why? It's a perfect cube, yep. Okay, so when you take out the 8, you are left with x cubed plus 27. Okay, and then we're going to break this down because it's a perfect cube. So I'm just going to write those parentheses. Your GCF always just stays on the outside. So if you just want to transfer it down, you can. And then your A value is x, what's your b value? 3. So some of them you might not need to write in this form. A lot of you, as you get better at this, you'll just be able to go here. So this would be x plus 3, a plus b, right? X squared, and then this is the opposite. So 3x, and then what's 3 times 3? 9. So the x cubed plus 27, that is x to the third plus 3 to the third. So your a value is what's inside the parentheses. You could also think of it as taking the cube root. So the cube root of 27 is 3. Okay, now for D, do we have a GCF? Okay, yep, 4. Anything else? Yep. And then when you factor that out, you get x cubed plus what? 27. Yep. And then look, didn't we just do that? Okay, so it is going to be the same thing. And I really should have made that minus, but I'll try again next year. That way you can see the difference between them. But yeah, this will be x cubed and then x squared minus 3x plus 9. And the 4x, again, stays on the outside. So don't forget the GCF in your final answer. Okay? We are going to change part B, so don't do that. That one definitely is Looney Tunes. I'll show you how to do this one if you want to, but I'm going to make it easier, so just if you're trying to work ahead. Okay, so when you're factoring, you are going to have a mix of some trinomials as well, so that GCF is absolutely something that you want to look for. So what number should we check to see if it goes into all of them? 4. Do you guys know if 4 goes into 180 right away? Because didn't last year in geometry, you talked about 180-degree angles? So half of 180 is 90 and half of 90 is 45. Okay, so you can take out 4. You can also take out a squared. Okay, so then now we're going to write this. So if I divide, I just am left with a to the 4th. If I divide negative 16 by 4, I get negative 4a squared. And then we just talked about how this is 45. Now, we do need to try to factor this down, and this is factorable. Don't be scared of the a fourth. We're actually going to be working with that more tomorrow. But when you have a to the 4th, you just split it up as a squared and a squared. So it's very similar to what you did before. And then you're looking for two numbers that multiply to negative 45 but add to negative 4. What are they? 9 and 5. Which one's negative? 9. Now, one of these can break down, one of them can't. The 9. So on 2 accounts, right? Because this is the only one with minus, and that's the only one with a perfect square. So a squared minus 9 becomes a plus 3, a minus 3. So you have to factor that down. This stays as part of your answer. It just drops down, and the GCF drops down. You could write it in every step if you wanted to, but I'm fine with you just dropping it at the end as well. This is your final answer. Okay, so for B, I'm going to change this to, instead of 128, we're going to do 1024. But I am making it easier, and I'll show you why. Even though I know you don't trust me now that I made the number bigger. But I am laughing because Emmy just responded like I would. Okay, so again, you're just going to take out the GCF. This is actually simple even though the number is bigger, because what are you taking out? 2. So when you take out a 2, you're just cutting this in half. What's half of 1,000? 500. What's half of 24? 12. So it's 512. So look at your chart. Yes, okay. So the y to the 6, that is something different, but the 512 is on your chart. Okay? And when you are breaking that down, again, you're thinking to yourself, what to the third power makes 512? Yes. And then minus, now again, you're thinking to yourself, what to the third power makes y to the sixth? Yeah, it is y squared. Because what do you do with the exponents? You multiply them. You don't add them. So it's not y cubed, right? So if you have y squared times y squared times y squared, that's what this means. That's when you have y to the sixth. If you tried to do it with the cubed, you'd actually have y to what power? Yep. So that's why you can't use 3 there. Okay? They multiply. All right. Now, I know this is also a little strange because it feels backwards. It's okay. We're gonna do the a like we always have. The a is always the first term. It's 8. The b is always the second term. It's y squared. And you're going to leave your final answer like this if they give it to you in this form. Okay? So this is just a minus b. So 8 minus y squared. Okay? And then in the second set of parentheses, it's a squared. So 8 times 8, 64. 8 times y squared, 8y squared. And then y squared times y squared is y to the 4th. And then the GCF just drops down. This is your final answer, okay? Remember I told you that wasn't factorable, okay? So the 8 and the y squared, that also cannot be broken down because 8 is not a perfect square, okay? Now, the original problem that I had on there, if you were to take out the 2, half of 128 is 64, right? The issue here is that 64 is a perfect square, so you would have had to factor it like this. 8 minus y cubed and 8 plus y cubed, and you would have had to do the difference of cubes and the sum of cubes. So you would have ended up with 4 parentheses, and that's just a little too much, right? Yeah. Yes. So your homework is going to be a worksheet, so I'm going to pass that out to you.